So the formula which relate resistance, area and length, as we discussed in the previous session, R is equals to rho L divided by A. If we are comparing the resistance of the two wires, of same materials, then the formula which we will use, that is equals to R1, the resistance of first wire, A1 over L1 equals R2 A2 over L2. So if I say a wire, two wires made up of copper having a different cross-sectional areas, this one is 2 meters square, this one is 5 meters square, and the length is 10 meter, and the length of the other part is 13 meters. The resistance of the first sample is 50 ohms. The question is, what is the resistance of the second sample? So when two wires are made up of same material, they will have the same resistivity. So we can compare their areas, length and resistance by using a formula R1 A1 over L1 equal R2 A2 over L2. So what is the resistance of the first wire? That's 50. What is the area? That's 2 divided by what is the length? 10. What is the resistance of the second part? We don't know. The area of the second part is 5 and the length is 13. So R2 is the subject. We are finding R2. So 13 is divided with R2. Other side it will multiply. And 5 is multiplied. Other side it will divide. So it will be 50 multiplied by 12. Multiplied by 2. Multiplied by 13. Divided by 10 into 5. That will give R2. So what's the answer? 50 multiplied by 2, 100. 100 multiplied by 13, that will be 1300. And 1300 divided by 50. So this 0 will cancel with 0. Then 5 multiply 2 and then 6, 26. So R2 is equals to 26 ohms. Is it clear? So if two wires, and this is only valid if two wires are made up of same material. If they're different material, then we cannot use this formula. Solve this example, calculate the resistance. So calculate the resistance of sample B. This is sample A. This one is sample B. 5 meters square. A length of 3 meter. And resistance is 20 ohms. 1 meter square. And length is equals to 15 meter. But we don't know the resistance. What's the answer? The resistance for sample B, this is sample A, this one is sample B. So use the formula R1 A1 over L1 equals R2 A2 over L2. First resistance is 20, area is 5, and length is 3. 500, okay. And second resistance, we don't know. Area is 1 and length is 15. So we need the second, so cross 15 is divided, other side multiply with 1, we don't have to change, so it will be 20 multiplied by 5 multiplied by 15 divided by 3. So this will be 5 multiplied by 5 is 25. So 20 multiplied by 25, that will make 500 ohms. Yes, R is a resistance. Is it clear? This example. Then resistance in a circuit. So we have a series circuit, a parallel circuit, or a combination of series and parallel. The SI unit of resistivity is ohm meter, because R is equals to, if I need the resistance of if I need the unit of resistivity, so we have the formula R is equals to rho L by A. So rho will be RA divided by L. What is the unit of resistance? It is ohm. What is the unit of area? It is meter square. And what is the unit of length? It is meter. So this will cancel with square. So you're left with ohm meter. So unit of resistivity is ohm meter. So resistance in a circuit, you may have a series circuit or you may have a parallel circuit. In a series circuit, if two or more resistors are connected in series and you want the combined resistance, the formula which we use to calculate the combined resistance is the total resistance or the combined resistance is equals to sum of individual resistance, so R1 plus R2. But if you want to calculate the resistance in parallel, like two resistors are there and they're connected in parallel to each other, to find the combined resistance, for two resistors, so when we are finding the combined resistance of two resistors connected in parallel like R1 and R2, so the formula to calculate the combined resistance, it is a product of the two resistance divided by the sum. This is only valid for two resistors when they are connected in parallel. So example, if I say a 10 ohm resistor and a 20 ohm resistors are connected in series, what is the combined resistance? A 10 ohm or 20 ohm are connected in series. What is the combined resistance of this series combination? So it will be 10 plus 20, that is equals to 30 ohms. And if two resistors are connected in parallel, like example 10, the same 10 and 20 are connected in parallel, and I need a combined resistance. So formula to calculate a combined resistance is a product divided by sum. So it will be 20 or 10 multiplied by 20 divided by 10 plus 20. So 10 multiplied by 20 is 200 divided by 30. What is the answer? 200 divided by 30, 6.67. So the combined resistance, the total resistance is 6.67 ohms. So what it shows when we connect the resistors in series, the combined resistance increases. When we connect the resistors in parallel, the combined resistance or the circuit resistance will decrease. So if we want to increase the circuit resistance, we should connect resistors in series. If we want to decrease the circuit resistance, then we should connect them in parallel. But you may have a circuit which is a combination of series and parallel. Like example, first two are parallel, and then with this component, another one is connected in series. And the question is find the combined resistance. Example, this is 20 ohms, this one is 40 ohms, and this is 10. So how to find the combined resistance of a combination of a circuit which is having both series and parallel? So first we will find one combination. So first these two are in parallel. So first I'll find the combined resistance of these two. What is the combined resistance of 20 and 40? To find the combined resistance, it is a product divided by sum. So 13.3. So basically the total resistance is 13.3 ohm for this part. And this part is now connected in series. So what is the total resistance of the circuit? So total resistance of a circuit will be 13.3 plus 10. That is equals to 23.3 ohms. Is it clear? This is how the resistors appear to be in the circuit. The strips are refers to the color coding. And this is a circuit symbol for a resistor. What is the resistance of this resistor? What is the resistance of this resistor? Resistance is a ratio voltage divided by current. So voltage is 15 and the current is 2. 15 divided by 2, that's equal to 7.5 ohms. If you want to measure the resistance, we connect a voltmeter in parallel and ammeter in series. The factors which affect the resistance, length of a wire and cross-sectional areas, as we discussed already, and the temperature, also the effect of temperature. It depends on the type of the material. So these two are connected in series. So 2 plus 8, that's 10. If they are connected in parallel, so product divided by sum. So what is the resistance of this part in which 2 and 5 ohm connected in parallel? What is the resistance? So it is 2 multiplied by 5 divided by 2 plus 5. So product divided by sum, 2 multiplied by 5 is 10 and 2 plus 5 is 7. So 10 divided by 7, you will get 1.42 or 1.43. What is the answer for this one? Calculate the effective resistance of the following resistors. The combined resistance. First, these two are in series and then series. And the series combinations are in parallel. The final answer. Look, these two are in series, so this total will be 10. These two are in series, this total is also 10. But that 10 ohm and 10 ohm are in parallel, so it will be product divided by sum. So 10 multiplied by 10 divided by 10 plus 10. So 100 divided by 20, that's equal to 5 ohms. So next time we will discuss the circuits in the next class. So we completed the voltage, current and resistance concept. Next week we will solve the questions from next week. I will send the discuss the questions from past paper as well as explain the circuits. All these presentation I have already sent on the group. I will resend again if you want. All the presentations I have sent for the whole course, but I will resend if you want. Any question related to the class? So I'll end the session and share this recording with you.